Transformations of absolute value functions. So the first type of transformation we're going to look at are translations, which are basically shifts, and we can have translations going up and down or left and right. So let's look at this first general form. Y equals the absolute value of x plus k. This, or a function in this form, is a shift or translation of the graph vertically, or in the y direction, k units up. Or if k is negative, then it would be k units down. For example, y equals the absolute value of x. Here is our parent function for the absolute value of x. Y equals the absolute value of x. It looks like a V. Its vertex is at the origin. Then let's look at the function y equals the absolute value of x plus 3. The graph looks like this, where the vertex and all points on the graph are translated up 3 units. It's easier to compare this transformation if you have both graphs on the same coordinate plane. So here you can see that the blue graph is the red graph shifted up or translated up 3 units. Okay, let's look at the general form. Y equals the absolute value of x minus k. So here the graph is shifted down k units. For example, if we compare y equals the absolute value of x with y equals the absolute value of x minus 5, we will see that the graph of the second function is shifted down 5 units. Okay, let's look at the second general form, or where we have y equals the absolute value of x plus h, where h is in the absolute value brackets. This is going to shift or translate the graph horizontally, or in the x direction, h units to the left. So we'll have our parent function again, y equals the absolute value of x, and we'll compare it to y equals the absolute value of x plus 2, which yields this blue graph. And if we put them both on the same coordinate plane, you can see that this new graph, the blue one, is the parent function shifted left 2 units. If we had y equals the absolute value of x minus h, this will shift the graph h units to the right. For example, if we compare y equals the absolute value of x with y equals the absolute value of x minus 1, the new graph is shifted right 1 unit. So try this. Graph both y equals the absolute value of x and y equals the absolute value of x minus 4 on the same graph. What is the transformation? So pause this while you draw the graphs and answer the transformation question, and then check back here. Okay, so our graphs look like this. The parent function is in red. The transformation of y equals the absolute value of x minus 4 is in blue. And the transformation is that the graph is translated 4 units down to create the new graph. Okay, let's look at the graph of y equals the absolute value of x and y equals the absolute value of x plus 3. And what is this transformation as well? So pause this while you look at the graphs and answer the question. Then check back here for your answer. Okay, again, the parent function y equals the absolute value of x is shown here in red. Y equals the absolute value of x plus 3 is shown in blue. And the transformation is that y equals the absolute value of x is translated 3 units left. Reflections, which are flips. Y equals a times the absolute value of x. If a is greater than 0 or a is positive, the function opens up like a V. If a is less than 0 or a is negative, the function opens down like an upside down V. In this sense, it's reflected over, the graph is reflected over the x-axis. For example, y equals 3 times the absolute value of x has a graph shown here in red. If we look at the graph of y equals negative 3 times the absolute value of x, we have this blue graph, which is the reflection of the original function reflected over the x-axis. Okay, we also have stretches and compressions. We have y equals a times the absolute value of x. If a is greater than 1, or a is less than negative 1, then the graph is stretched and looks thinner. If a is in between negative 1 and 1, then the graph is compressed and looks wider. For example, we'll compare again to our parent function, y equals the absolute value of x, here in red. Then y equals 3 times the absolute value of x, shown here is the original function stretched. If we look at y equals 1/3 times the absolute value of x, so this is the value of a that's in between negative 1 and 1, we have this green function, which is compressed vertically and looks wider. So we can combine these transformations. So a general form is y equals a times the absolute value of x minus h plus k. So we have a, h, and k that we've seen throughout our transformations. This is considered general form. hk is considered the vertex where the point of the absolute value function is. And the axis of symmetry is the vertical line x equals h. The absolute value of a is the stretch or compress factor. So for example, y equals 3 times the absolute value of x minus 4 plus 2. The vertex is the point 4, 2. The axis of symmetry, that's AOS, is the vertical line x equals 4. And the function is stretched by a factor of 3. Let's look at another example. Y equals 2 times the absolute value of x plus 3 minus 8. Here the vertex is negative 3, negative 8. The axis of symmetry, and the reason why is because x plus 3 is the same as x minus negative 3. So that's where the negative 3 comes from for the vertex. The axis of symmetry is x equals negative 3. And this function is stretched by a factor of 2 when compared to the parent function.